Humans have gazed at the stars and wondered if there is life on other planets. After all, Earth possesses such an unusual, almost perfect combination of conditions that it feels tailor-made for life. So it seems obvious life must have evolved countless times across the vast universe. And that part is probably true. But the real question, the much harder, far more haunting question, is this. Are we alone in the universe? The silence is deafening. Not a clue, not a hint, only cosmic noise. What are the odds that intelligent life may have evolved anywhere? Based on the evidence, none. In this video, I'm going to take you on a journey through cosmic history using a radically different perspective. By examining the astonishing odds of our own existence in the Milky Way galaxy, we will attempt to estimate the odds for the emergence of intelligent life. Considering that there are roughly 1 trillion potentially habitable planets, the odds of simple life existing in the universe is almost certain, and the odds of intelligent life is probable. Keep in mind that there is a quantum leap between simple life and intelligent life. The James Webb Space Telescope is the most powerful eye, yet despite its incredible power, no unmistakable signs of life have been found. After examining thousands of planets, some habitability-related gases were detected on WASP-39b, TRAPPIST-1b, and Kepler-442b, hinting at life. Exoplanet K218b potentially has a 99.7% chance of hosting life because it has a biosignature of dimethyl sulfide, DMS, a molecule produced by marine life. NASA's Kepler Space Telescope found over 6,000 planets in the Goldilocks zones, but don't pop the champagne yet. No proof of life. Let's examine the incredible series of cosmic events that turned Earth into a true incubator for complex life. The universe is vast beyond comprehension, so we will focus only on our own galaxy, the Milky Way, with its 200 billion plus stars. Are we alone in the universe? It is time to take a deep dive into this captivating subject. The famous Drake equation tried to calculate the answer, but by today's standards it feels painfully naive, built on too many unknowns and far too much wishful thinking. Enrico Fermi, one of the greatest physicists of the 20th century, looked at the size of the universe and asked a simple, devastating question. If the universe is teeming with life, where is everybody? Since the 1960s, the SETI program pointed its telescopes at the stars and listened, decade after decade of silence. One brief moment of hope came in 1977, the famous wow signal, but it never repeated. The cosmos remains eerily quiet. Perhaps we are listening in the wrong spectrum. Rather than emitting omnidirectional radio waves, advanced civilizations may use highly structured, pulsed light to minimize energy waste. And advanced alien life may use quantum communication, qubits, making their signals undetectable, or technology advanced beyond our comprehension. Let's start at the very beginning, at the Big Bang. Here's the shocking truth. Our universe would simply not exist in anything like its current form if two very specific, razor-thin events had not occurred in that first unimaginable instant. Without them, life on Earth as we know it, and anywhere else, would not be possible. The universe is vast beyond comprehension, so we will focus only on our own galaxy, the Milky Way. The first cosmic battle was fought in a trillionth of a second after the Big Bang. The war between matter and antimatter. In an incredibly close contest, matter won, but only by the slimmest possible margin. An antimatter universe would be equally vigorous, but radically different. The second decisive battle involved the Higgs field. In 2012, physicists at CERN confirmed the existence of the Higgs boson. If the Higgs field had been even slightly different, atoms could not form, stars could not shine, and the entire structure of chemistry and physics would collapse. The path that eventually led to human existence was already written by these two events, 13.8 billion years ago. Location, location, location. The universe is a cosmic war zone. Galaxies collide, stars are shredded, black holes devouring everything in their path. Inside our own galaxy, most places are not safe for life. Fortunately, our solar system sits in a remarkably peaceful, quiet neighborhood, far from the shooting galley and the deadly radiation of the galactic center. Closer to the galactic center, cosmic radiation alone would have sterilized any chance of life before it could begin. Our sun orbits at the perfect safe distance, allowing our planet to flourish for 4.5 billion years in the habitable zone, and it will continue for billions more. A location with a view, at 26,000 light years from a supermassive black hole at the center, it is the perfect safe distance. We ride the outer edges of the Sagittarius and Perseus arms in a stable orbit that has protected us long enough to thrive. Earth formed out of less than 1% of the materials from a collapsing solar nebula. Yet we received exactly the right mix of elements to spark evolution: carbon, hydrogen, oxygen, and nitrogen, plus 12 other trace elements necessary for advanced intelligent beings. But chemistry was not enough. From that point on, the road to intelligence became an unbelievable chain of random, contingent events. Bipedalism, tool use, language, cognitive leaps, and ruthless natural selection. Every single step was a roll of the evolutionary dice. So what were the chances for our survival? Our voyage is convoluted and extraordinary. We will focus only on the highlights of our incredible journey. Roughly 4.5 billion years ago, a Mars-sized world called Theia smashed into the young Earth in a glancing but cataclysmic collision. The impact was so powerful it melted vast portions of both planets, vaporizing rock and ejecting a massive cloud of molten debris into orbit. Out of that hellish chaos, the debris coalesced to form our unusually large moon. This single random event gave Earth one of its greatest guardians. The moon stabilizes our planet's axial tilt, preventing wild wobbles that would cause extreme climate swings. It also creates strong tides that mix nutrients along coastlines, likely playing a key role in the origin of life itself. Thanks to the moon, we enjoy relatively stable seasons and the long-term environmental consistency that complex life demands. Protection of our planet started with the moon, but it is also shielded by a powerful magnetic field, generated deep in its molten core, a field sustained and strengthened by plate tectonics. Trapped within this magnetosphere are the Van Allen radiation belts, two donut-shaped zones of highly energetic charged particles. These belts act like a planetary bodyguard, deflecting deadly solar radiation and cosmic rays that would otherwise strip away our atmosphere and bombard the surface. Without this invisible shield, most life on Earth would have been destroyed long before complex organisms, let alone intelligent beings, could ever evolve. Remarkably, no other planet has been detected with this combination of a strong, stable magnetic field and a large moon working in harmony. Together, the violent birth of the moon and the protective embrace of the Van Allen belts helped create the safe, stable sanctuary that allowed life to move beyond simple microbes and eventually give rise to us. Jupiter is the solar system's gentle giant, our fateful guardian. Its enormous gravity acts like a cosmic shield, deflecting and capturing countless asteroids and comets that would otherwise slam into the inner planets. Without Jupiter standing guard, Earth would have suffered far more frequent and devastating impacts, likely preventing the long, stable periods needed for complex life to evolve. Jupiter also played a key role in delivering our oceans. Many of the water-rich asteroids and comets that bombarded the early Earth were shepherded inward by Jupiter's gravitational influence, helping us inherit the precise amount of water that made life possible. Our planet's size and position was exactly in the right habitable zone. Even more remarkably, Earth's interior and plate tectonics created a long-term water cycle. The mantle acts as a vast reservoir, slowly exchanging water between the surface and the deep Earth. This recycling prevented our planet from losing its oceans to space over billions of years, as happened on Venus and Mars. These conditions created the perfect cradle for the origin of life in tidal pools, and later supported the explosion of complex multicellular life, then intelligent life. Without our planet's perfectly balanced oceans, the story of humanity would never have begun. What if I told you that earthquakes beneath your feet are one of the main reasons your existence? Plate tectonics is not just a geological curiosity, it's one of the rarest and most powerful life-promoting processes in the universe. Unfortunately, earthquakes are part of the process. It shaped our world by acting like a planetary recycling system. As continents drift and plates dive beneath one another, they pull nutrients like carbon and phosphorus from the crust and bring them back to the surface through volcanoes. Without this constant renewal, life would have starved long ago. Even more importantly, plate tectonics regulates our climate. It powers a global thermostat. Volcanoes release carbon dioxide, while the uplift of new mountains accelerates rock weathering that pulls CO2 out of the air. For hundreds of millions of years, this balance kept Earth's temperature stable enough for complex life to flourish. Plate tectonics also gave us rich, concentrated resources. Metals, minerals, and energy sources forged in the fires of volcanism. These materials became the foundation for human technology and civilization. In the end, plate tectonics didn't just keep Earth habitable, it turned a living planet into the perfect crucible for intelligent life capable of reaching the cosmos. Life as we know rests on RNA and DNA molecules, delicate as they are powerful. In 4 billion years, Earth has seen an explosion of 50 billion species come and go. Only 8.7 million remain today. Our own family tree, from ancient primates through Australopithecus, Neanderthals, Homo sapiens, and finally us, survived on the razor's edge of extinction. At multiple points in history, we almost became extinct. Our species had a remarkable ability to adapt to a dynamic environment. Failure along the way could have ended the entire journey forever. Another freak event acted like a catalyst for the emergence of Homo sapiens. 66 million years ago, catastrophe struck. An asteroid slammed into what is now the Yucatan Peninsula with the force of billions of nuclear bombs. 75% of all species on Earth were wiped out in a mass extinction, a cataclysmic event with a silver lining. It was a lucky break for humans because it allowed a small mammal, Purgatorius, to survive, and that led to the evolution of all primates, including humans. Our survival was an arduous journey that could have ended countless number of times. We continued to face monumental challenges tossed in our path by nature, but against all odds, here we are. Another event that challenged human endurance. 74,000 years ago, the Toba supervolcano in Indonesia, the largest eruption in Earth's history, exploded with apocalyptic force. It triggered a 6-year global volcanic winter. Humanity was reduced to a few thousand individuals, teetering on the very edge of extinction. In our early history, our ancestors lived in dangerously small populations, facing calamity that could have ended our existence, but it didn't. We dodged ice ages, climate shifts, diseases, resource wars, and population bottlenecks, and survived. Barely. So the question remains, how likely is intelligent life in the universe? We are forced to base that answer on our own existence, for lack of any other tangible evidence. Human history fits perfectly into the rare Earth hypothesis, out of a sample of one. Scientists have tried to model this using an overwhelming number of variables: exponential decay models, Bayesian probability, population genetics, Markov chains, adaptive landscape models. The list goes on. When you combine every razor-thin cosmic event, every fortunate galactic location, every lucky planetary condition, every near-miss extinction, and every improbable evolutionary step, the numbers become almost incomprehensible. Perhaps that is the uncomfortable message. It is time to wrap our heads around reality, the moment of truth. What were the actual odds of our existence? Drumroll. The calculated odds for human existence come out to 1 in 10 to the power of 2,685,000, or 1 followed by 2.8 million zeros, a number so small it defies the imagination. All of this leads us to one inescapable conclusion. Intelligent life on this planet was an extraordinarily rare convergence of countless precise factors. When we consider every razor-thin cosmic event and every improbable evolutionary step, the number becomes almost incomprehensible. It is possible that we are the first advanced civilization in our galaxy, and it took 4 billion years of evolution to get here? Yes, we may be the first and truly alone, for now. Not just in our solar system, but quite possibly in the entire galaxy. Maybe even the observable universe. Let that sink in. Using limit notation, this number approaches 0, but never reaches it. So it is highly unlikely but possible under extreme, bizarre circumstances. The ultimate question remains, could there be intelligent life elsewhere? We may never know the answer, but does it really matter? The question becomes largely academic because we cannot meet an alien face-to-face. Physics simply guarantees it. Yes, we are alone. The rare Earth hypothesis suggests that complex multicellular life, and especially intelligent technological civilizations like ours, is extraordinarily rare. It demands an almost impossibly precise alignment of astrophysical, geological, and biological conditions. In this vast but finite universe, we stand as something truly one of a kind. After all that time, the universe may have finally produced a species capable of reflecting on its own improbable existence and deciding whether that journey continues. The silence from the stars is no longer just mysterious. It may be a profound call to responsibility. We are the precedent setters, the first known beings with the power and the ethical duty to preserve conscious life, not only for ourselves, but for any young civilizations that may one day follow. And yet, here we stand at a perilous crossroads. The doomsday clock is now set at just 85 seconds to midnight, dangerously close to humanity's self-inflicted global catastrophe. The very intelligence that carried us this far now threatens to undo everything, because we've handed a handful of people the power to end all life on Earth. So the question is no longer simply, are we alone in the universe? It has become far more urgent. How intelligent are we really? If we allow our planet to spiral into this quagmire, we are the universe becoming aware of itself. And that awareness, so rare, so precious, so fragile, may be far more fleeting than we ever imagined. The choice is ours. The stars are watching. What will we do with our one precious chance? Will this brilliant spark continue to shine, or will it flicker out after one brief, shining moment in the history of the cosmos?